Today we're diving into the fascinating world of friction in physics. Friction is a force that resists the motion of two surfaces sliding against each other. It's something we encounter every day, whether we're walking, driving, or even just picking up a book. Without friction, life as we know it would be very different. Imagine trying to walk on an icy surface all the time. In this video, we'll explore what friction is, why it matters, and how it shapes the motion of objects around us. Let's start by understanding the basics of this essential force. Friction is everywhere in our daily lives. Think about when you walk on a sidewalk, your shoes grip the ground thanks to friction. Or when you rub your hands together to warm them up, that heat is produced by friction. Even writing with a pencil relies on friction between the pencil tip and the paper. These everyday examples show just how important friction is for our routines and activities. It keeps us safe, helps us move, and even lets us create art. Now let's look at the science behind how friction actually works. The microscopic level, no surface is perfectly smooth. Even objects that look polished have tiny bumps and grooves. When two surfaces come into contact, these irregularities catch on each other, creating resistance to motion. This resistance is what we call friction. The rougher the surfaces, the more friction there is. That's why sandpaper feels much rougher than glass. Understanding these surface interactions helps us see why friction varies from one material to another. Friction isn't just one thing, it comes in several types. The main types are static friction, which keeps objects at rest, and kinetic friction, which acts when objects are moving. There's all rolling friction, which occurs when an object rolls over a surface, and fluid friction, which happens when objects move through liquids or gases. Each type of friction plays a unique role in how things move and interact. Let's break down each type and see where they show up in real life. Static friction is the force that keeps an object at rest, preventing it from moving until a certain amount of force is applied. For example, when you try to push a heavy box on the floor, it doesn't move right away. That's because static friction is holding it in place. Only when your push becomes strong enough does the box start to slide. Static friction is usually stronger than kinetic friction, which is why it takes more effort to get something moving than to keep it moving. Once an object starts moving, static friction gives way to kinetic friction. Kinetic friction is the force that resists the motion of two surfaces sliding past each other. For instance, when you slide a book across a table, kinetic friction is what slows it down and eventually stops it. Kinetic friction is generally weaker than static friction, which is why it's easier to keep something moving than to start it moving in the first place. Rolling friction occurs when an object rolls over a surface, like a car tire on a road or a ball rolling across the floor. Rolling friction is usually much less than sliding friction, which is why wheels and ball bearings are used to make movement easier. This type of friction is crucial in transportation and machinery, helping things move smoothly and efficiently. Fluid friction, also known as drag, happens when objects move through liquids or gases. Think of a swimmer moving through water or an airplane flying through the air. The resistance they feel is fluid friction. This type of friction depends on the speed of the object, the viscosity of the fluid, and the shape of the object. Engineers often work to reduce fluid friction to make vehicles faster and more efficient. Friction plays a vital role in keeping us safe. Car tires grip the road because of friction, allowing us to stop and turn safely. Without enough friction, vehicles would skid and accidents would be much more common. The same goes for shoes. Rubber soles provide the friction needed to walk without slipping. Engineers design materials and surfaces to maximize friction where safety is a concern. Athletes rely on friction in almost every sport. Soccer players need friction between their shoes and the grass to run and change direction quickly. In basketball, the friction between the ball and the court allows for dribbling and precise movements. Even swimmers and cyclists work to reduce friction to move faster. Friction can be both a friend and a foe in sports, depending on the situation. When two surfaces rub against each other, friction converts some of the kinetic energy into heat. That's why your hands get warm when you rub them together. In machines, this heat can cause parts to wear out or even fail if not managed properly. That's why lubrication is so important in engines and moving parts. It reduces friction and helps control heat. Machines are full of moving parts and friction is always present. Sometimes, friction is useful, like in brakes that stop a car. Other times, it's a problem, causing parts to wear out or waste energy. Engineers use lubricants, ball bearings, and special materials to control friction and make machines more efficient. Understanding friction is key to designing reliable and long-lasting equipment. Friction isn't just a human concern, it's everywhere in nature. Animals rely on friction to move, climb, and hunt. Geckos, for example, have special toe pads that create friction, allowing them to walk up walls. Snakes use friction to slither across the ground. Even plants use friction to anchor their roots in the soil. Nature has evolved countless ways to use friction for survival. While friction is essential, it also causes wear and tear. Over time, the constant rubbing of surfaces can break down materials, leading to damage or failure. This is why car tires eventually go bald and why shoes wear out. Engineers and designers must balance the need for friction with the need to minimize wear, often by choosing the right materials or adding protective coatings. In many situations, reducing friction is important for efficiency and longevity. Lubricants like oil and grease are commonly used to create a slippery layer between surfaces, making it easier for them to move. Ball bearings and rollers are also used to convert sliding friction into rolling friction, which is much lower. These solutions help machines run smoothly and last longer. Sometimes we want to increase friction for safety or performance. For example, car tires are designed with treads to grip the road better, especially in wet conditions. Athletes use special shoes to maximize friction on different surfaces. Even the rough texture of a matchstick helps it ignite when struck. Increasing friction can be just as important as reducing it, depending on the situation. Friction always converts some of the energy of motion into heat, which is often lost to the environment. This energy loss can make machines less efficient and increase operating costs. Engineers work hard to minimize unnecessary friction in engines, motors, and other equipment to save energy and reduce waste. Understanding where energy is lost helps us design better, more sustainable technology. Transportation systems depend on friction in many ways. Trains rely on friction between wheels and rails to move and stop. Airplanes experience fluid friction as they fly through the air, and ships deal with it as they move through water. Engineers must balance friction for safety, speed, and fuel efficiency. Innovations like aerodynamic designs and special tires help manage friction in modern vehicles. Weather can have a big impact on friction. Rain, snow, and ice reduce the friction between tires and the road, making driving more dangerous. That's why winter tires and road salt are used to increase friction and improve safety. Understanding how weather affects friction helps us prepare for changing conditions and stay safe on the road. Construction workers and engineers use friction to their advantage when building structures. Nails and screws hold materials together because of friction. Heavy equipment relies on friction to operate safely on different surfaces. Even the foundations of buildings are designed to use friction with the ground to stay stable. Friction is a hidden but essential part of construction. Modern technology often depends on controlling friction. Touchscreens, for example, use just the right amount of friction to make swiping easy but precise. Computer hard drives and other devices use special coatings to reduce friction and prevent wear. As technology advances, finding new ways to manage friction becomes even more important for performance and durability. Do you know that friction can create sound? When you rub your fingers on a surface or drag a chair across the floor, the vibrations caused by friction produce noise. In music, instruments like violins use friction between the bow and strings to create beautiful sounds. Understanding how friction produces sound helps us design quieter machines and better musical instruments. In space, friction behaves differently because there's almost no air or other materials to create resistance. Spacecraft rely on tiny amounts of friction when docking or landing on other planets. However, when they re-enter Earth's atmosphere, they experience intense friction with the air, which creates heat and requires special heat shields. Friction is a challenge that engineers must solve for space exploration. Throughout history, inventors have found creative ways to use and control friction. From the invention of the wheel to modern ball bearings and lubricants, managing friction has driven technological progress. Today, researchers are developing new materials and coatings that can change friction on demand, opening up exciting possibilities for the future. Friction can also be harnessed to generate energy. For example, wind turbines and hydroelectric dams rely on friction between moving parts to produce electricity. Even simple hand-crank generators use friction to create power. While friction can waste energy in some cases, it can also be a valuable source of energy in the right context. In medicine, friction plays a role in everything from surgical tools to prosthetic limbs. Doctors and engineers must carefully design medical devices to have the right amount of friction for safety and comfort. For example, artificial joints use special materials to minimize friction and wear, helping patients move more easily and comfortably. Artists use friction in many creative ways. Drawing, painting, and sculpting all depend on the friction between tools and materials. The texture of a canvas or the resistance of clay can influence the final artwork. Understanding friction helps artists choose the right materials and techniques to achieve their vision. Even in the kitchen, friction is at work. Chopping vegetables, kneading dough, and grinding spices all rely on friction. The texture of cooking surfaces and utensils can change how food is prepared. Chefs use friction to their advantage, whether it's creating a crispy crust or blending ingredients smoothly. Clothing designers consider friction when choosing fabrics and designing garments. Some materials create more friction, which can help clothes stay in place or provide warmth. Others are smoother, making them more comfortable for movement. Even the grip of athletic wear or gloves depends on the right balance of friction. Safety features in transportation like anti-lock brakes and traction control are designed to manage friction. These systems help drivers maintain control in slippery conditions by adjusting how much friction is applied to the wheels. Advances in technology continue to improve safety by giving us better ways to control friction on the road. Friction has played a role in human history for thousands of years. Early humans used friction to start fires by rubbing sticks together. The invention of the wheel was a breakthrough in reducing friction and making transportation easier. Throughout history, understanding and controlling friction has led to major advances in technology and society. Friction can have environmental impacts, especially when it leads to energy loss and increased fuel consumption. Reducing friction in engines and transportation can help save energy and lower emissions. Engineers are developing new materials and technologies to make machines more efficient and environmentally friendly by minimizing unnecessary friction. Friction is also part of our fun and games. Slides in playgrounds, roller coasters, and even board games all use friction in different ways. Sometimes we want less friction for speed, like on a slide, and other times we want more, like when rolling dice. Understanding friction helps us design better toys and games for everyone to enjoy. Friction is a popular topic in science experiments. Students often explore how different surfaces affect the movement of objects or how lubricants change friction. These experiments help us understand the principles of physics in a hands-on way and inspire curiosity about the world around us. Engineers face many challenges when it comes to friction. They must design machines and structures that balance the need for grip and movement with the need to minimize wear and energy loss. Innovations in materials science and engineering are helping us solve these challenges and build better, more efficient technology. Robots rely on friction to move, grip objects, and interact with their environment. Engineers design robot hands and feet with special materials to control friction for precise movements. As robots become more advanced, understanding and managing friction becomes even more important for their performance and versatility. Our bodies use friction in many ways. The grip of our hands, the way our feet interact with the ground, and even the movement of our joints all depend on friction. Skin, muscles, and bones are designed to create just the right amount of friction for movement and stability. Understanding friction helps doctors and therapists treat injuries and improve mobility. Adhesion is closely related to friction. It's the force that makes things stick together, like tape on a wall or glue holding objects. Adhesion and friction often work together to keep things in place. Scientists study these forces to develop better adhesives and materials for everyday use. At the nanoscale, friction behaves differently than it does with larger objects. Scientists are studying how friction works at the atomic and molecular level to develop new materials and technologies. Nanotechnology could lead to breakthroughs in everything from medicine to electronics by controlling friction in innovative ways. Renewable energy systems like wind and hydropower must manage friction to operate efficiently. Turbines and generators use lubricants and special materials to reduce friction and increase output. As we move toward cleaner energy, understanding friction helps us design better, more sustainable power systems. The study of friction continues to evolve. Scientists and engineers are discovering new ways to control and use friction for everything from faster computers to safer vehicles. As our understanding grows, friction will remain a key factor in innovation and progress across many fields. Teaching about friction helps students understand the physical world and inspires curiosity about science. Hands-on experiments, demonstrations, and real-life examples make learning about friction engaging and memorable. Educators use friction to connect physics concepts to everyday experiences. Understanding friction helps us solve problems in engineering, design, and daily life. Whether it's fixing a squeaky door, designing a new product, or improving athletic performance, knowledge of friction gives us the tools to find effective solutions. Problem solving often starts with understanding the forces at work. Creativity often involves finding new ways to use or control friction. From inventing new sports equipment to designing innovative products, creative thinkers use their understanding of friction to make life better. The next big breakthrough could come from someone who sees friction in a whole new way. As we wrap up, remember that friction is an invisible but powerful force that shapes our world. From walking and driving to building and creating, friction is always at work. By understanding and managing friction, we can make our lives safer, more efficient, and more enjoyable. Thanks for joining us on this journey through the science of friction.